All right, well, the mean is right there in the center, and one standard deviation is about 68%. Two standard deviations is about 95%. Three standard deviations is 99.7. And so I've indicated here the middle is 68%. And this is one standard deviation above the mean. This is one below the mean. Positive one standard deviation, negative one standard deviation means one below the mean. And if I were to go, of course, out two places, now we're talking about 95% of the data. All right, so that's the empirical rule. I remember one textbook I taught of called it the rule of thumb. All right, I want to see, as you can see, the standard deviation is a yardstick. It's a measuring stick. It measures a width of sorts on this curve. And so the data, if the data is widely spread out, then you need a larger yardstick. You need larger standard deviations to measure. If the data is very closely packed together, so suppose it's like this, then your standard deviation numbers are going to be very small. For example, when I teach elementary algebra in the fall, or beginning algebra, the grades on the first test can range anywhere from just about 0 all the way up to 100. It just, the full range, the full gamut. It's got a very large standard deviation because the grades are widely distributed. There are people in there who just have no business in college for whatever reason, or they just need to take something lower. They bomb that first test. And there are people that are really good. They get hundreds. Now, in this course, when I first started teaching this course, I had nothing but nursing majors from Wright State. It was life and death that they get a good grade in here, and they all studied very well, very good learners. And the standard deviation was small because on the midterm, for example, the lowest grade might be a 68, highest might be a 96. And so instead of running from 0 to 100, it ran from maybe 68 to 96, had a much smaller standard deviation, a smaller dispersion of the data. All right, so that kind of my illustration of standard deviation. Now, it turns out we use that standard deviation as extremely important in calculations. Mean, standard deviation, and sample size tell us a great deal about the data that we're studying. They're summary statistics, very important summary statistics, tell us a lot. All right, I want to check out the empirical rule with this example just to see if it comes in close. And now, the empirical rule is not a hard and fast rule. It works best when the data looks the most like a bell curve. When the data doesn't look like a bell curve, then it doesn't work quite so well. And so let's see what happens with this data that I made up. And all right, so the middle 68%. If I take the mean and subtract a standard deviation, and the mean and add a standard deviation, then this would be the interval from 5.4 minus 1.7 to 5.4 plus 1.7. And that would be between 3.7 and 7.1. All right, so let's see how many numbers fit into that range. All right, so 5, 7, 5, 6, not 3, 4, 5, not 9, 6, and 4. All right, so if I did that correctly, it looks like all but two numbers. So this came out to be 80%. 80% fell in between. Now, the empirical rule predicted 68%. When I do this problem, normally I get about 70%, which with 10 pieces of data, 70% is the closest you can get to 68. So this was slightly unusual. All right, let's try two standard deviations from the mean. So in that case, I'm going to take my mean, x bar, add 2 s's, 2 standard deviations. I'm sorry, I meant to subtract. We might call that a subtraction. And then we'll take x bar and add 2 standard deviations. There we go. And this would be 5.4 minus 2 times 1.7. 5.4 plus 2 times 1.7. That would be 5.4 minus 3.4 would be 2. And 5.4 plus 3.4 is 8.8. Alright, so I picked up this number 3, but not 9. 9 fell outside that, so this would be 90%. The empirical rule predicted 95%. So, and we got 90%. And you know what, when I do this problem with 10 numbers, about half the time I get 90%, about the half the time I get 100%. Below that is 95. So for me it works out pretty much on the money. If I went to 3 standard deviations, it would encompass 99.7% of the data, and which is almost everything. And I'm sure it would capture the 9, and we would see 100% here. So it's actually pretty unusual to see more than 3 standard deviations. It's not out of the question, but 3 standard deviations covers almost all data. And so anything that's either greater than 3 standard deviations above the mean or less than 3 standard deviations below the mean is sort of an anomaly. It's rather unusual. The largest I've seen that actually occurred from theoretical data is 5 standard deviations. And that was the coin flip problem I mentioned in an earlier video. One time I flipped the coin, simulated on my computer, flipped the coin 100 times and got 75 heads, 25 tails, and that turns out to be 5 standard deviations. It's that's such a large number for standard deviations, it's not even in your textbook. It has to be computed by calculus means. Anyway, now we're going to use that standard deviation to make decisions. And I'm going to try to give you an example in this chapter 4 of how that's done. And this sort of foreshadows what we do in chapter 7. But I'd like to kind of give you a heads up and where we're headed with what we're doing. Get those wheels a turning on the statistics. All right, so but give me a little while on that.